Right, here we go, looking at questions from 23 onwards on the what might come up in the next paper. So a logo is designed that has 4 pink circles with a white square. Square's side length 16 centimeters. Find the area of the logo that is white. So the total area is the square, which is equal to 16 squared, which is 256. The circles equals 4 times, now we know that distance is going to be 8, and that distance is going to be 8, so the radius is going to be 4, so it's going to be pi times 4 squared, because we're using pi r squared for the area of a circle. So that's going to give me 64 pi, so therefore the white will equal 256 minus 64 pi. We can get our calculator to calculate what that is, because it wants us to find that out. I'm just trying to see what the accuracy was. There was no degree of accuracy given, so let's set myself a new line. Oops, just get it down there. Right, 256 times by, so not times by, minus 64 pi. That gives us 54.93, so on. So 54.93, let's just get the next figure, 3, 8, and so on. I would probably give this to just 3 significant figures, if in doubt. Although in GCSE, the more places you get, the less likely you are to be penalised. Okay, you only get penalised if you round more than the question asks. Here we go, right, just go through this again. Right, next question. We've got calculate the perimeter of the sector. So we've got a sector. We want to find the perimeter. So we need all these lengths. And the arc length, which is the curved bits round the outside. So the arc length is this bit here. Is given by theta over 360 times 2 pi r. Or pi d, doesn't really matter. What you need to remember is just the fraction of the circle. And we can work out the fraction of the circle by using the angle. So it's equal to 285 over 360 times by 2 times by pi times by the radius 4. And then the perimeter will equal that answer there. So let's just work that out. So it's 285 divided by 360 times by 2 times by pi times by 4. Let's just check the right number. So it gives me 19.896. 19.896. Add on 4 here and 4 here. So it's going to give me 27.9, should we say, to 3 significant figures. And if you want to write more, 27.896 and so on. Okay, whatever your last number is, make sure you've rounded it correctly though. Okay, don't just truncate. This is a truncation because I haven't even bothered to look at it. If you look at the number, it would have been rounded up. I would have had to change that into a 7 to get that correct. Okay, next question. Shown is a sector of circle radius 9.2. We know that its area is 38.4. Now we know that the area of a sector is again just a fraction of the area of a circle. So we take this fraction and times by pi r squared. So long as you remember the area of a circle is pi r squared and the circumference is 2 pi r, the sector and arc length formulas are very easy to remember, just times by theta over 360. Now we know that 38.4 will equal theta over 360 times by pi times by 9.2 squared. So therefore, let's get everything to the other side. I'm going to have 38.4 times by this 360 and divide by these two terms, pi times 9.2 squared, and that will give me theta. So bung that into my calculator. And I get 38.4 times 360. And what I've not done here is I've not put a bracket around that. Clever machines worked out how to do it all. Be careful with your calculators. Pi times by 9.2, and I want to square that value. And the answer comes out to be 51.988 51.9886. So it's two significant figures. Don't confuse the two decimal places. There's two significant figures. So therefore, I'm going to need to round up because this is a 9. So it's going to be 52 degrees to 2SF. To calculate the value of x, I've got one angle. I'm going to probably need this side. So that's going to be the easiest way. So let's take this triangle here. Okay, that's 50. That's 5. There's my right angle. So I'm going to use tan. That's the hypotenuse, that's the adjacent, that's the opposite. Tan of 50 will equal the opposite over the adjacent. So therefore the adjacent is 5, so I get 5 times tan 50 equals the opposite. Now I'm going to save myself some time and not work the opposite out. Now this is now my adjacent and this is my opposite in the next triangle. So therefore tan of 38 will equal the opposite x over the adjacent, which is all of that, 5 tan 50. So therefore x will equal tan of 38 times by 5 tan 50. And I'm just going to grab my calculator to do that, because I definitely can't do that in my head. So I want to do tan of 38 times by 5 times by tan of 50. And I get 4.655. I'm going to round that to three significant figures, so 4.66. Rounding to three significant figures because we have a 5 here. Okay, number 27. So we have a prism made from wood of mass 643 grams and density of wood equals 1.85. So D equals 1.85 grams per centimetre cubed. Now, if you can't remember the formula, here's a brilliant way to remember the formula. The units give it away. That's mass, that's volume. So density equals mass divided by volume. There you go. The units tell you what the formula is. So we know the mass and we know the density. We know 1.85 equals 643. Now we've got to be careful. That's grams. So good. It's all in the same units. That's in grams. That's in grams. So we're okay just to carry on. 643.8 over the volume. So therefore the volume is equal to 643.8 divided by 1.85. Now we also know our volume, okay, is equal to the area of this triangle times by that length. So the area of the triangle is a half times 8 times 6 times x. So we know that a half times 8 times 6 times x will equal the volume, which is just 643.8 over 1.85. Notice I don't work things out before I need to. Half times 8 is 4. 4 times 6 is 24. So I have 24x is still equal to that value above. So therefore that x will equal 643.8 over 1.85 divided by 24. So get my calculator again. It's getting a lot of use today. 643.8 divide by 1.85 divide by 24 gives me 14.5 centimeters. Exactly. Okay, Timothy weighs mass of oranges. The table shows some information about his results. Work out an estimate for the mean mass of the origin. Now, the key word, the reason why it says estimate, it doesn't mean guess. It means you're going to approximate. We've got 12 things here, and we don't know any of the masses apart from the fact they're between 20 and 25. So we estimate by using the midpoint. That's why it says estimate. So you're going to make the midpoint 22.5. This one 27.5. This one 32.5, and this one, what's it going to be, 37.5, and this one 42. 22.5. And then we times these together. And if you wanted to, you could work those all out and get the sum here. So this is a sum of the x times the f. So I'm going to call those the f, so I'm going to call that x. I'm not actually going to work out all those individual ones. I'm just going to work this all out in one go. And this is how I do it. So I'm going to do 12 times 22.5 plus 24 times 27.5 plus 17 times 32.5 plus 15 times, what's it, 37.5 plus 4 times 42.5. And I get 2,215. Now, if you've got time in the exam, I would suggest you do work all those individual things out, just in case you made a mistake. Now, we got 215 for total mass. Okay, and now the common mistake is go 1, 2, 3, 4, 5 things, divide by 5, and if I divide this by 5, what I'm going to get? I'm going to get roughly, it's going to be roughly 400. Bit more than 400. Now you can see none of the masses of these oranges are 400. I'm assuming the mass is in grams. Okay, none of them are more. Actually, well, none of them are more than going to be 400. Okay, so that's a daft thing to do. We divide by the sum of how many oranges there are, and this is how many oranges are. There's 12 plus 24 is 26. 36. What's that? 43, 53, 58. And 4 is 62, it would seem. Okay, I might just, I can gamble, that's right. I'm going to do answer divide by 62. And I get 35.7. Let's check that again. 35.7, that's correct rounding. So 35.7 grams for your average tomato. And we can just have a look, see, does that make sense? So we'd expect it to be around about here is the middle value. I'm surprised it's 35.7 because I've got more of the smaller values than I have of the bigger values. I'm just going to quickly check my adding again. So that's 36, 46, 53, 63, here we go, I have made a mistake, 63, 68, it's actually 72. Now, let me just go through how I spotted I'd made a mistake there. What had happened was, I'd realised that this is the middle value, round about here, 32.5, and yet my average had come at more than 35. So it's more than this, and yet there's less of these than there were of these. So it's more likely to be lower than the middle value than it is to be higher than the middle value. So that's why I spotted my mistake. So if I go back and divide by 72 instead, I get 30.76, which is 30.8 grams to 3SF. And that is now below the middle point, which is what I expected. Okay, in a small village, 1 bus arrives a day. The probability of the rain in the village is 0.3. If it rains, the probability of the bus being late is 0.4. If it does not rain, the probability of the bus being late is 0.15. Complete the tree diagram. So, easy thing to remember, these must add up to 1. Okay, so therefore this is going to be 0.7. They must add up to 1, so that's 0.6. They must add up to 1. I haven't even looked at the question. I just know my branches must add up to 1. So that's 0.85. So that was quite easy, 2 marks. You can remember pairs of branches, and if you have 3 branches in a section, then those 3 must add up to 1. Okay, you must be certain. It must be certain of all events are covered. Work out the number of days the bus should be late over a period of 80 days. So we ought to work out the probability it's late first. So the probability it's late is going to be that one, and this one is 0.3 times 0.4, and this one is 0.7 times 0.15. So just put that all into your calculator. So 0.3 times 0.4, which is 0.12, isn't it? Plus 0.7 times 0.15, get to 0.225. Okay, we times along the branches and we add up down the ends, because these are that and that. So when you have an and, you times, and this is this or this, and or we add situations. Now that's 1 day. So over 80 days, we're going to get 80 times 0.225. Okay, so we can times that answer. I know, just answer times 80, and that gives us 18. So we'd expect on average 18 days to be late. Now this doesn't mean that it will be late exactly 18 days, it's just what we expect on average over time, given our question. Okay, a group of friends has been surveyed. 38% been to Canada, 80% to France, 11% been to neither Canada or France, 5% of the group have been to Canada and France. Well, let's just draw a Venn diagram. So I'm going to get myself a big square and get myself a circle. Just move that a bit. Copy. Just move it. There we go. Overlapping a bit. Right, got myself a Venn diagram. So we've got Canada and we've got France. 38% have been to Canada, 80% to France, 11 have been to neither. So we know 11's here. So we know what's going in here must add up to 89. But we've got 38 to Canada and 80 to France. Now 38 plus 80 is equal to 118. So the overlap must be 118 minus 89. So that's going to be 11 plus 18. So that's going to be what? 28, 29. So the middle here is going to be 29%. So Canada is going to be 9% in there. France is going to be, what's that? Going to be 51 in there. So 5% of the group have been to Canada and France. So our answer is the middle bit here. There's Canada and France, 29%. One of the group who has visited Canada is picked at random. So we've now reduced our Venn diagram down to just this yellow area. That's Canada, the group of Canada. So it's out of 38% of the group. We're just looking at, we know that's happened. Final probability they've been to France. So therefore, out of our 38, 29 had been to France. And that is our probability of going to France if we know they've been to Canada already. Okay, histogram we got here. Remember that the histogram, the frequency is proportional to the area, okay, or the area is proportional to the frequency. Probably a better way of writing it. Area is proportional to frequency. Okay, so it's one key thing to remember when doing these questions. So the area is proportional to the frequency. So what we're going to do is we're going to try and work out our frequency density. In fact, they've been very kind here and given to us. So let's just check that there is what they the same as theirs, so their scale. Normally, I would say ignore their frequency density and make your own up. But actually, theirs matches the table because you do 4. If you take the class width, in this case is 40, this case is 20, this case is 10, this one's 10, and this one's what? That's 40. And the frequency density only has to be proportional, not equal to, the frequency divided by class width, which is 0.1 in this case. We don't know that. That's 3.3, and that is going to be 464. It's going to be 0.4. Okay. But in this case, that is 0.1 there. Okay, and this is 0.4. And the other one we've got 3.3 was a 60 to 70. It agrees there. So if it doesn't agree, just use your own frequency density. Yes, because then it'll be much simpler to work with for the rest of it, and you can just ignore the numbers they've got. Now we know that this one The 40 to 60 is 2.4 high. So it's going to be 2.4 times 20 for the frequency. So we're going to have 40 plus 4/10 of 20, which is going to be 4 times 2, which is 8. So what did I say? 48. And then we've got this one's 10 wide, and we know that it's 3.9 high. Times that by 10 is nice and easy. That's 39. Now, what we want to do, we want to calculate an estimate of the median. So we've got to work out where 50% of the group occurs. So we need to find out where the error gets us to 50%. So what I'm going to do is I'm going to work out the cumulative frequencies. 4. 48 onto 4 is 52. 33 onto there is 85. Okay. Now I know that my median must be in this group. So it's going to be at least 60 times 60. And I want to find out what fraction into this group I'm going to go to. So I want the 70th value, because half of 140 is 70. So I want the 70th value, which is going to be 18 people, 18 students into this group. So I'm going to do 18 students into this group, and the group is 33 big. So it's going to be that fraction of that group. And the width for that group is 10. Okay, so I'm going to times that by 10. And that will give me my estimate for my median, if I assume that these students are evenly distributed in this group. So I'm going to grab my calculator to work that out. It is not looking very friendly. So 60 plus 18 divided by 33 times by 10, in the wrong place, so do be careful when you times straight off without thinking. Times by 10 gives me 65.4545. So I would go for 65.45 seconds. Let me just recap how to do that, because that's quite a tricky technique. Okay, it's not a standard histogram question, part B. So you know that you've got 52 people take up to less than 60. So the 70th person will be in this group here. 70th person's in this group here. Now, if you take away the 52 that were already in the groups before that, we know, sorry, just change the colour there. So we know that 52 in the groups before that. So there's only 18 that we're interested in before we get into that group. So there's 18 out of the 33 who are going to be less than our median, or take us to our median. So we do 18 divided by 33, and then we times by the class width for the group to work out what fraction we're going to go into that group to get our median value. Okay, Mrs. Hampton is potting plants. She's using two mathematically similar pots. The smaller is 10 centimetres tall, the larger is 14 centimetres tall. She has 2 bags of soil, each containing 30 litres of soil. With the first bag, Mrs. Hampton fills 20 small pots using all the soil in the bag. How many large pots can be filled completely using the second bag of soil? So, we know that the length scale factor here is going to be times 1.4. So if the length scale factor equals times 1.4, the volume scale factor will be times 1.4 cubed. So let's just cube 1.4. 1.4 power of 3. So it's 2.744. That's our volume scale factors. That tells you what's going on with the volumes. This one's 2.744 times the volume of this one. So, which has 2 bags, each containing 30 soil. She's got 20 small pots using the soil in the bag. So this was 20. She managed to get out. Now, obviously, this is going to take up 2.7 times as much soil per pot. So therefore, we want to do 20 divided by 2.744 to find how many large pots she can do. So that gives us 20 divided by answer equals 7.28 large pots. There are other ways to do this, but I think that's the quickest and the easiest way, 2.88. So she's not going to get more than 7 completely filled. Okay, so it says it's got to be completely filled. The 8th pot only gets partially filled with soil.